Looks like I had a blue screen, so of course, when you're trying to do something like a webcast, that's the best time to get one of those. Just give me a second, I'll get my deck back up. See my starting slide all over again? Okay, good. Sorry about that. I guess take two, we'll start over again. This is real world web pen testing. I will hopefully be able to do some demos today after I go through some slides. My name is Jason Gillam with SamuraiWTF. This is a topic that I enjoy a lot. It's something that's, I've done a lot in my past. I come from an application development background. So moving from that into web application pen testing was sort of a natural path for me. And so hopefully I'll be able to pass on a little bit of my expertise and knowledge and wisdom for you. If you have any questions as I go through, please use the GoToTraining chat and put them in there for now. You should know that this is being recorded. So if you miss part of it or have to step out or want to go look at it again, I'll be signing up. Everybody who signed up for this and paid for it will get access to the recording in our online learning management system. So that'll be available as well. All right, so without further ado, I will move into this, hopefully. There we go. So first of all, for anybody who hasn't seen SamuraiWTF before, just a quick overview of who we are. We are first and foremost known as a penetration and testing and a security consulting company. We do a variety of different things. One of those is we like to spread our knowledge. So we do education and training. Like this webcast here, we also do longer training sessions as well. Anyway, we're also very well known for application security, although that isn't exclusively what we do. Just our history kind of has us in that area as known experts in the field. So one of our, I guess, most notable ways of identifying us is the tagline, professionally evil. It's not just a tagline, it is kind of cool. I like it, but really what this is, it actually has an important meaning to it, which is that ability to go into either a system or an application or looking at a device or network or what have you, and really assessing it from the point of view of an attacker. But we do so in a professional fashion. So we have that professional part of the tagline there. And what that is for us, that is, we make sure that we always have permission when we're doing any sort of pen testing. It's important to note that some of the stuff that you will see in this presentation even, including some of the demos, are going to use tools that could get you in trouble if you use them against a website that you don't have permission to test. So, so just bear that in mind. I warned you. So today's agenda, I'm going to go through a little bit of introduction, and then I'm going to do a walkthrough of the penetration testing overall process. And that's something I don't think we've done that before to this extent in this type of training. So that's something a little bit new. Hopefully, be able to pass on some nuggets of knowledge there. And then we're going to go through some demonstrations of the types of things we would actually do during a penetration test. Okay, if you are in the mood to follow along, or if you want to later on when you're looking at the recording, there's two options for you. I'm going to use Samurai web testing framework for the demos. So everything that you need to kind of walk along or follow along with it, if you want to do so locally, is inside of that virtual machine. So if you have Vagrant and VirtualBox already set up, or you're familiar with it, then you can always get the latest stable release on GitHub. You can build it yourself, actually. So the link's there. It's in the SamuraiWTF repo, and it's just as simple as cloning that repo and doing a Vagrant up. If not, then we have our little domain shortener domain that we snagged, tiny.si, and if you do /samurai on that, the latest version of that we've released there will be available. That one is actually 4.1 is a little bit aged. I think it was uploaded in late November or December, but everything that you need is still in there for what we're doing today. So. Okay, so starting in, why is application security so important, and penetration testing in particular? Well, I'll just go through this quickly. Basically, everything that we encounter, everything that we have on the network these days, it all tends to have applications that are user-facing as part of their deployments. Okay, so we have the obvious stuff, consumer-facing business applications, your online banking, your email. Most of that's online too now. Almost all of your office stuff is online. Everyone's moved to the cloud, right? You have even all of your personal stuff. So people tend to trust the internet or the web with everything that they have. All of their important information is there. So if you look at social networks, people regularly treat what's in there as private, even though it's not necessarily. That's something I have to reinforce with my kids all the time, right? So if you're putting stuff on Facebook or Twitter or whatever Instagram or whatever the latest thing that the kids are using, they have to be cognizant of the fact that it's not necessarily 100% secure and private, and anything you post there could be there for a very long time. So that's just something to keep in mind too about applications. There's a lot of applications that we don't necessarily see, or at least we don't see them on the internet, or we shouldn't anyway. So some of these would be like every single device the network device out there now, well, most of them anyway, tend to have some type of user interface on them as well. So when we're doing an internal network pen test, we run across often many interfaces there, and a lot of the time, some of those are not secured properly. We have applications in healthcare in particular that are may be considered life or death applications, right? So you have computers hooked up to the systems that are keeping people alive, or that could be used to help resuscitate them. So it's another case where applications are important. We all have them in our pockets. We take them with us everywhere we go. So yeah, application security. It's an area that we want to spend some time looking at from a security perspective, because it's of all of the different things that you could do in technology, applications tend to be some of the more complex, and that's because they're for interfacing with people, they're the user interface, and people are complex, right? So it might seem simple on the when you just look at it on the screen, like you look on there and there's whatever 3 buttons and a little menu system and what have you, but all of the stuff that happens between what you see inside your browser and what actually goes on in back-end systems, there's layer upon layer of abstraction and complexity there, and so there's lots and lots of opportunities for errors to occur along the way. The other thing is typically web applications, especially those that are internally developed, the priorities tend to be business priorities. It's all about getting the application shipped within a certain timeline or to meet certain certain goals of releasing a certain type of functionality within a certain time for a particular time period, and it's a lot of it's driven by time to market. So the result, of course, is security priorities tend to be behind the business priorities. So another case of there's many examples out there of applications where more security testing would have been a good idea. So and we still find a lot of application security flaws to be very prevalent. So even the stuff that we've known about for years still shows up a lot. Okay, so basic walkthrough. First thing I'm going to mention is just a quick little my opinion of the difference between like using automated tools and manual pen testing. And although automation has its place, especially if you're looking at integrating some types of tests through your SDLC, if you're doing continuous integration, continuous deployment, that's definitely something you want to look at, is how much of that can you automate. Unfortunately, there's a lot of things that can't really be feasibly automated that still need to be tested. So that's where a person comes in. People can understand context very easily. AI is not quite at that level yet. So, and without AI, it's really just a program that's doing what it's told. So you, and it's bound by that. So they tend to be, for automation, they tend to be very expensive to maintain if they're actually working. So. And that's because somebody has to sit behind it and help direct it and give it more context, do the thing that people can do. Manual pen tests, you can always look for something that just, as you're going through a web application, you might see something that just doesn't look right. And you'll know. You'll look at it and say, hey, something about this is weird or doesn't look right. I need to dig into it further. And so you kind of know, you can drive how you're doing your tests based on what you're seeing. So there's that intuition is a part of it. That's the word I was looking for. So this doesn't include every type of flaw. This is just some examples. So I have some examples of vulnerabilities in that left-hand column on there. And what I've done is I've kind of tagged each one for how is that type of vulnerability, how easy is it to test for automated versus manual testing, manual pen testing. And you can see that some of them, such as injection attacks, those are trivial to do through automated systems, just in the sense that you can program how to look for a particular type of injection attack, and then you can automate checking for that across your entire application. So it checks all of the inputs for that same type of attack, and that's something that's very easy to automate. Obviously, it's more effort to do that manually. It's not really that much harder. It just takes more effort because it's what's hard is not missing things. If you look at authentication session management flaws, testing those in a way that's repeatable in an automated fashion is actually very difficult. I'm not saying it's impossible, but it takes a lot of effort to come up with a system that's going to be able to test the various different things that could be wrong with authentication or with session management. From a manual perspective, a lot of that's actually, it's trivial. It's pretty easy to test once you know how, and once you know where to look. Access control flaws, kind of the same thing. If you look at some of the client-side stuff, cross-site scripting, cross-site request forgery, well, they're actually, those two are a little different. So cross-site scripting is about the same for both, I would think. Cross-site request forgery, on the other hand, it's nearly impossible to actually to test that in an automated fashion. And I know some people are like, well, wait, we have scanners that do that. What I've seen is, in most cases, the scanners that do that, what they're really looking for is cross-site request forgery tokens. So they can look for those tokens across all of your forms. And yeah, that much they can do. What they can't do very well is actually test if the cross-site request forgery is control is properly implemented, or if it's working effectively. And that is something that's actually very easy to do if you're a person. It also doesn't really know where to look, because an automated system doesn't understand whether or not a particular function call is sensitive in nature or not. So that's something else to consider there. And then configuration, patch-related flaws, obviously automated systems are better at those. And then logic flaws, they are just not going to be able to figure those out. They don't understand the business logic of an application unless you have a script that's been specifically programmed to do that. So, so anyway, if you take a look at that, the right side of this table, what you'll notice is that in the automated section, things are either really complex or very easy. And there's not really that much that's in between, whereas manual is all kind of in that moderate and trivial range. Okay, so most things we can test manually. There's a lot of things that, from an automated perspective, we just can't really do a good job of testing it at all. So now the pen testing timeline. This is based on my experience, so your mileage may vary. So scoping, we'll start off with scoping. Usually half-hour meeting is enough. If you have demonstrations of an application, which is actually not a bad idea, it could take a little bit longer, especially for a bigger application. And then the next step, I'd say, is preparing for the test. That doesn't mean we're spending 1 to 2 weeks of effort preparing for it. What I mean is 1 to 2 weeks in calendar time, you're going to spend doing things like getting accounts set up, making sure that the testing team has access to it, to the environment that's being tested. For some tests, the amount of preparation is minimal. There's very little that's really required, because maybe it's an application that's already on the internet, easy to get to. Setting up user accounts is trivial, or maybe there's a self-registration. So there is the easy side of that scale, and then there's the harder side. It's an internal application in a special environment. We need VPN to get to it. We need to stand up a whole separate environment for it, maybe. So that it can range from very easy to quite a few tasks. So we want to give ourselves time for those. And then the actual testing, for us, we typically, most of our tests fall within the 3 to 5 calendar day range, with 1 to 2 testers, depending on the size of the application. Really large, complex applications could go into a second week, so we could have up to 10 business days of actual testing on an application. Usually no more than that, though. And then reporting. So once you're done the testing, actually getting the report together and walking through all of the the various different steps for reproducing issues and so on and so forth, and having people review it. That's again, depending on the size of the report, could be anywhere between 3 and 10 days too. All right, so scoping is the first thing we're going to do. We want to determine, what is the level of effort that we need to do for a test, and this goes for both third parties like ourselves if we're doing a test for you, and it also is important internally too. I know that when I was working with an internal team at a large enterprise and scoping out pen tests, it was a, like I said, a large enterprise, so things tend to move kind of slow, right? And course corrections can take a while. So we really needed to get the scoping right, because we would be trying to stack up, you know, the order of the tests that we're going to do and make sure that we had everything scheduled with enough time to do each one. You know, that's why that becomes important internally. For third parties, it all comes down to how much are we estimating our cost is going to be for the test, right? So that all feeds into that. So so when we're scoping it, there's two sides of the scoping. One is the business purpose, business/purpose side of the application. So we'll cover that first really quickly. Most important thing on here is that first question: what does the application do? At Secure Ideas, we've tested hundreds of applications. If your application does something that's even semi-normal out in the world, you know, maybe it's a banking app or an inventory application, or it's an estimation tool for things, or I don't know, bookstore, or other like online commerce. There's so many different applications out there that you know, it's not that if you build something, somebody else already has built the exact same application, but if it has the same basic business purposes, then the chances are we've either tested that one or something very similar to it, right? So just knowing what it does is often enough for us to estimate how much effort's going to be involved. The other thing is who uses the application. So and we're talking about roles here. Is this something that's customer facing, or is it employees that are using it? Is it a call center? Is it something for managing information within an HR system? You know, who's using the application? And also to that point, what sort of data and functionality can users access? So that's going to drive some of the scope there. The other side of the scope, remember I said there were two parts. One is the business side, the other is the technology. So it helps for us to know when we're scoping what the technology stack is. Okay. None of this is absolutely required, but the accuracy of our scoping is impacted by all of these. So the technology stack definitely helps. It's nice to know whether it's you know, a modern stack. Is it running out in the cloud? Is it or is it running on some legacy system, or is it, you know, is it PHP or Perl based or something like that? You know, those still happen. So we want to look at that. We want to know where the application boundaries are, and this kind of gets into a little bit of the architecture. So it's good to know, like, for example, does it authenticate through a separate single sign-on system? And what does that sort of look like? So you know, some of that's sometimes helpful. It's good to know what else might be in scope other than the user interface part of the application. Are there APIs? Is infrastructure just as a whole in scope? Sometimes even for an application pen test, we might get just an IP range to work with. And then also, you know, any other services that are in scope as well. There's different types of tests. Okay, we have white box, gray box, and black box are sort of the ways that we categorize these. Starting at the bottom, for a black box test, we're not really given any information at all except for where the test is. And this is those three terms are used for any type of pen test. I'm talking specifically from an application pen testing perspective. If it's a black box test, we're not given any information about the application. Those tend to be very limited value. My preference is to go for either a gray or white box test. So in a gray box test, we have more information. We'll have accounts for us, so we can immediately go in and log in and start using the application. And then we also may have some idea what the high-level architecture looks like. So some kind of high-level architecture diagram or something like that, just so, especially if it's a complex application, so we understand what the moving parts are. And then a white box test, would be most common for those of you doing an internal test. And it is going to have, in addition to knowing the location and accounts and such, access to either the people who are writing the code for the application, or possibly even access directly to the source code itself. And that just gives us a lot more transparency into what the application is doing. Another thing that's actually not on this list that's helpful for white box too is access to what operations folks might see. So if we can see the application logs or get access to those, that way when we break something, we get an error on the application, we can go and check and see in the logs and figure out exactly what happened, and that helps us test to a greater degree of detail, which is pretty awesome. I really like white box tests as a third-party pen tester coming in, consulting company. Most of what I'm going to do is gray box, but I see a lot of value with the white box as well. So next, preparing for the test, we want to have access to our environment, user accounts, source code if it's a white box test. All of that stuff needs to be, anything that we're going to need needs to be provisioned ahead of time. We don't want to be starting to do that the day that we're also scheduled to start the test. And so we want all of that stuff ahead of time. This other thing that we want to take a look at is scan interference. Okay, so this is kind of an important thing because this comes up a lot, is if you happen to have security controls in front of the application. So firewalls or web application firewalls is the big one that happens a lot. So if those are sitting in front of it, it doesn't help us test the application if we're not whitelisted for that control. Okay, if we're not whitelisted, what that's going to do is that we're going to spend a great degree of effort just testing that control instead of the application. So we need to be whitelisted. If we find a vulnerability, we also need to know that the WAF is there, because what we can do is, if we find a vulnerability, we can then go and test from a non-whitelisted source and see if the WAF rules actually prevent that attack from occurring. All right, so we can still test that control. We just don't want to focus our test on that control. So we want to start off whitelisted, and then we have the option of also testing from a non-whitelisted IP. We also want to make sure that these days, I mean, for application pen tests, the goals tend to be find my vulnerabilities, not a challenge to see if I can get in and pivot. Not to say that that's not fun and that's good to do once in a while. I'm just saying most pen tests, it's really all about find my vulnerabilities. So that being the case, we want to do it in a collaborative fashion. Usually not super stealthy is not one of the goals. So letting the ops center know that, hey, this test is going on, here are the IP addresses of our testers, is a good thing. All right, so we want to set that up. And then we want to conduct a kickoff call, and I'll just jump straight to the next. During the kickoff, we'll want to review everything, especially the rules of engagement. So what do you want me to do if I find something egregious, or if I find signs of compromise? Also, what are the overall objectives of the test? We also want to finalize the scheduling and timing of what our test is, and specifically, we want to know when is the testing starting and when is it ending, and also, are there specific test windows during the day that we want to either test within or to avoid. So some examples are some applications have processes around them that have scheduled outage time or downtime. So we need to know about that ahead of time too. So that's something we would want to cover in that meeting. And then finally, we're going to have a communication plan of some type. So for that, what we want to know is first of all, who are the primary points of contact? So who do we talk to if something goes wrong, if we can't access the application, if it appears to be down, or if we think we broke it, or if we need our user counts, passwords reset. You know, there's a variety of things that can go wrong in a pen test, and we need to know who do we talk to as we encounter those. It's a good idea to have more than one point of contact. We've had, I can think of 2 tests over the last couple of years where we did our kickoff call, and we had a single point of contact, and then we started in on the test and then tried to communicate back, and then that person was gone. And that just makes things very chaotic for a while. You know, the person could be laid off, or maybe they just left. And if you're not privy to that, then and you don't have a secondary point of contact, then that kind of leaves you in a bad spot. And then also, how do they want updates? So some organizations prefer to have meetings. My preference is to do email unless we find something that warrants a meeting. So it's a good idea to have daily updates of some type. Oh, there we go. Okay, so once we get into the actual test, we follow a 4-step methodology. Recon, mapping, discovery, and exploitation. This is the formal methodology. What it really tends to look like is more like this. And on this particular slide, what I'm showing is 2 things. First of all, notice that the arrows go to anywhere, because although our formal methodology is to kind of start at one step and move on to the next, and then the next, and then the next, we tend to move around throughout the application, or throughout the test through the application from one part of it, then we find something very interesting and quickly see if we can exploit it, and then we move back to mapping, and then so on and so forth. So it kind of jumps around a lot. The other thing that this slide shows is, I guess, a weighting of the amount of effort that we would spend in each step normally for a gray box test. Recon or reconnaissance, the types of things that we're going to do there will include, we're going to, we ask ourselves, you know, what are the types of things that we can look at for this application, without actually getting into the application and doing stuff. And I just saw there's a question on there. Do we have access to the slides? Yes. I tell you what I'll do is I'm going to take these slides afterwards, and I'll export them as a PDF, and I'll put them on the LMS site along with the video. So you have both. So we're going to do the reconnaissance, like I said, and some of what we're looking for there, one of the big things these days is if you go to like GitHub, for example, so if there's public repos out there related to the project that you're testing, then we're going to look through those to maybe see some source code. Sometimes it's not necessarily the code, but maybe the repo for the environment. And we find things like API keys in them, right? So someone's deploying to Amazon, and their API key is actually sitting inside the repo, or maybe it was sitting in there and they deleted it, but it's still in the history for the repo. You know, those types of things we're going to be looking for. Or we might also look at Stack Overflow or other, you know, online forums to see if we can find information regarding a test, right? So that's some of the stuff that we'll be looking at. The next step on there, mapping. So mapping is actually, notice that that's the second largest box on there. What mapping is that's walking through the application and understanding what it does, and not just from the user interface perspective, but also looking at the request and response traffic as we're going through it as well. Mapping is extremely important to get right, and this is what actually differentiates from a fully automated test from to a manual pen test, because we are taking the time to understand the business context of everything that that application does. We understand the roles, what's the difference between the roles that are on there, where are these sensitive transactions and sensitive data surfaced inside the application, and then when we look at the request and response traffic, we can also look at that to see, you know, how is the application maintaining state, where is it maybe moving information from within the application to other applications, or shipping stuff to other domains. You know, there's lots and lots of things that we can discover through mapping. So it's worth you know, spending a fair bit of time there and fully understand the application. Discovery is where we probably spend most of our time. So once we've finished mapping and we have a good idea of what the application looks like from a normal user perspective, then we move into the, okay, well, put on our attacker hat and let's see, you know, based on what we know about the application, where would be some potential places we could attack it. And I know I've said numerous times, you know, we won't do any, or we want to focus more on the manual pen testing and not the automated. Parts of discovery and exploitation can still be automated. I just want to be clear on that. That the way I say it is we're basically doing a manual test, and we supplement that manual testing with automation where it makes sense to do so, not the other way around. Because what we don't want to do is pass off what's really a vulnerability assessment and call that a pen test. And then finally, exploitation. We don't spend as much time as exploitation as you might think. Mostly going back to what I said before about the typical goals of a application pen test are find all my vulnerabilities, right? So we're more concerned with that and less concerned with you know, how far can I get through exploitation. So we'll do it where it makes sense to prove out the vulnerability, to do proof of concept, that sort of thing. Typically, going into an application and pivoting inside is going to be out of scope once you get past a certain point anyway. So the amount of time we spend there is limited. All right, next slide. Okay, so what are we looking for inside the application? Part of what we're looking for is here. So if you haven't heard of the OWASP Top 10, I'm betting most of the people on this webcast have heard of the OWASP Top 10 at some point. These are critical application security risks, according to the OWASP. So this is not considered a comprehensive list, but it gives you a good starting point for the types of things that that you're going to want to look at anyway. So I'm not going to go through all of the items on this list. We'll talk about some of them later on when I get into the demonstrations. And to reiterate again, it is not a complete list of what to test. Okay, and one reason I mentioned that is because we've actually had clients ask us to put this into our statement of work language to say, hey, we're testing the OWASP Top 10. If I skip back a slide just for a second, looking at A10, insufficient logging and monitoring, unless I'm doing a white box test and I have access to your logging and monitoring, there's no way I could assess that during a gray box test or a black box test. So, you know, there are things that are not really testable, at least through a pen test in the OWASP Top 10. Anyway, but there's also things that are not on that list. There's things that have been removed from previous ones. We usually refer to that top 10 list as the David Letterman list of application vulnerabilities, right? So it's what are the top 10 current trending ones. It's not all of the things that you need to look at. So other things that we're looking for, I tend to break them up into 3 or 4 buckets. And these are the ones that I use, right? So Authentication session management. So when I'm testing an application, I'm going to spend part of my time just focusing in on authentication session management. So we want to know, how are users logging into the application? How is that session being maintained? Are there ways to abuse that? Are there username harvesting flaws? So on and so forth. Okay, so hang on. I'm going to take a quick step back here because there was a question that I think is a good one for the previous slide. So, do you ask clients about their monitoring to make sure that control is covered during testing? We often do. We don't always get feedback on that, but if we have an open dialogue with our clients, which we prefer to have during tests, what we'll do is we'll say, hey, we just did this sort of exercise here. We tried to log in 5,000 times. Did you guys pick that up in your logs? And see what they say. And depending on the answer on that, that is information that we can include in the report, because they may say, oh yeah, we detected that. We didn't do anything because we knew you were doing a pen test, but we did detect it. So, and then that's a positive note for the test. Good question. Okay, so going back to the slide here. So I talked about authentication session management flaws. Of course, anywhere where there's sensitive data exposed or sensitive functionality. So any flaws around that, are there ways to get to sensitive data that we shouldn't be able to? The next one is, I had originally just wrote injection flaws, but I realized afterwards that when I'm thinking about it, going through an application, what I'm really looking for are any ways to manipulate input, right? So I have data going into the application that may let me mess with things on the back end in various different ways. So, so we look at all of the inputs, try to figure out what they do, and are there ways to manipulate them? And that may result in injection flaws. And then the last bucket I look at, I kind of separate this one out from the input manipulation, even though some of that is also input manipulation, is the client-side flaws. So, and that's things that involve like cross-site scripting, cross-site request forgery, abusing forwards and redirects. So basically things that you can use to attack the users in their browser in various different ways. So, and I kind of look at those separately as well. So there's two major tools that we're going to use for a pen test. The first one of those tools is your browser, okay, which I don't have a slide on that one, but that one, you know, goes without saying. Browsers have come a long ways. I will say this, that the dev tools that are baked into browsers these days are fairly sophisticated, and they do a lot of what we need directly in them. And there is a certain amount of pen testing that you could do just with a browser, right? So any company that's saying to their employees, hey, you know, we're not going to allow people to install hacking tools on their laptops. Well, they all have browsers. So, and you can actually do a fair bit of hacking just through the browser. You don't need to have any other tools. But once you get past that set of what you can do inside the browser, and you want to start looking at the request and response traffic, we do really need to use an interception proxy. So what this lets us do is it lets us man in the middle our traffic so that we can see the HTTP requests and the responses that come back, and that way we can see what do all the inputs look like as it's kind of like, you know, how they're flowing with the request, and what do the outputs look like as they come back to us. It also lets us tamper with that traffic, right? So we can take a request and then we can replay that request over and over again, making changes to it to, you know, see what we can manipulate. And you can also do a certain degree of automation with that as well, and also kind of gives us you know, a full historic record of everything that we did, and we'll be looking at some of that in a second. Two interception proxy tools that are available. There's more than two. There's A couple others that you may have seen is Charles and oh, I'm gonna blank on it now. Charles is one, and then there's I can't believe I'm forgetting it. But there are other tools that you can use that are interception proxies. These two that are on the screen right now, Z-Attack Proxy and Burp Suite, are the only two currently in the industry that have, I guess, everything baked into it that you would need. They're true Swiss Army knives for doing pen tests. Others could be used for software development fairly effectively, but these two are specifically for penetration testing. So Z-Attack Proxy is an open source project. It's part of OWASP. Last I checked, it was still being maintained, and it has functionality that's pretty close to what you get inside of Burp Suite Pro. Burp Suite Pro is from a company called Portswigger, and that is a commercial tool. They have a free version. It has limitations on it, so that's cool for kind of checking it out. But the commercial version is my go-to. In fact, all of us at Securities, that's what we use. Not so much because it's commercial, you get commercial support. It's more comes down to the user interface. I like the user interface on that better. It just than Zap. I've played around with Zap a few times and used it in a few tests, but Burp Suite, I overall I like it better. I'm more comfortable with it. So yes, somebody just mentioned Fiddler in the chat. Thank you. That would be the other big one. So Z-Attack Proxy both of these are actually inside of Samurai. The version of Burp Suite that's in there is the free version, so the commercial one's not in there. However, if you drop the commercial jar file into your the Samurai home directory and then click on Burp, it'll actually bring that up instead. So it's sort of a smart little script on there. And yes, so another question another point that's been brought up in the chat is that you can use them in tandem. So both of these proxies allow you to set up upstream proxies. So some people will do that as well. So you can probably do basically a proxy chain. Okay, I'm getting near the end of the first part of what I'm doing here, so I want to get through this here. So the notes are really important. So if you're doing a pen test, or if you're receiving one, it's good to know that they're actually doing this right. If you're doing a pen test, your notes are going to be in a few different spots, right? So one of those is your proxy history. So if you're using Z-Attack Proxy or if you're using Burp Suite, both of them, they do keep a log of every single request and response. So that's one thing that you can hold on to and you can reuse. Inside of Burp, at least, I know that you can take any of those requests and then you can revisit it in your browser later on as well, which is kind of interesting. And lets you go back if you missed a screenshot or something like that, then you may be able to recreate it. You also want supporting screenshots for everything. I tend to take screenshots even of things that are just interesting but not necessarily a vulnerability in case I need them for my report. And then there's your activity log. And the activity log is the activity log is basically, the way I look at this is it's not a, I don't think of it as like a time-stamped log of every single thing that you do. Your proxy history is going to do some of that, but you do want to keep track of things that you attempted. So I tried username harvesting here, and it either worked or it didn't work. You want to keep track of stuff, even if it's not a vulnerability, but it was things that you tried. That'll become important later on. So if you've ever been involved in a pen test, you know that As you're going through it, everything seems to make sense and it's clear in your head. Then within a couple of days, sometimes even a couple of hours, it starts to get a little, your memory gets a little foggy about what exactly did you test, what did you mean to test or think about going back to, and even for the stuff that you tested, what order did you do that in? Those types of details, your brain tends to start mixing them up after a bit of time, or at least mine does. So it's good to keep those just some simple notes in order, because that way, if you're trying to reconstruct a narrative later on, it's a whole lot easier. So hang on, I'm going to go through. I saw that there was some more commentary on here in the chat. Okay, somebody posted a video. Oh, saving sessions is limited to Burp Suite Pro. That's true, yeah. You can't, a lot of the automation and the saving of sessions is only available in the Pro version. Oh, one other thing on notes is if you are negatively impacted somehow, like the application's not available when you're expecting it to be available for part of your test, or if it changes, that's one of my pet peeves is I'm doing a test on an application and then the dev team starts pushing code changes that are fixing the issues that I'm finding as I'm finding them. That can be very annoying because it makes it harder for me to prove that the vulnerability was found. So, okay. Couple more quick slides here. So reporting is the most important part for anybody who's on the testing side of things. You have to realize that ultimately that report is what you're handing over to your client. It doesn't matter if you're an external team or an internal team, that's what you're giving to them. So that's what they get to take with them. Really important that you do it and that you do it right. So the things that you want to do inside your report, you need to be objective, use empirical evidence. Basically, we want to explain everything based on facts during the test and try to avoid being subjective as much as possible. So that's usually fairly easy to do. If you're using screenshots, if you're having putting down the steps to reproduce things. Like all of that's usually fairly easy to stick to the empirical evidence that you have. You also want to explain anything in terms of the true risk to the organization as much as possible. And sometimes that part becomes a little bit subjective because ultimately you're probably not going to explain it in terms of how many dollars are at risk, but not for this type of conversation, but you can speak to, in relative terms, this type of vulnerability is a greater risk than this other type of vulnerability because of X, Y, and Z. So we do that. Things that you want to avoid inside of a report. Don't name or embarrass individuals. I mean, sometimes you can put down names if it doesn't embarrass the individuals, but especially in an executive summary, that's area that's not something that you should have in there. Even though you may have some contention. I've had lots of pen tests where the team that I'm working with, security team, is very happy that I'm doing the test, but the dev team is not very happy that I'm doing the test, and so that creates some contention. And then the other thing you want to avoid too is stating absolutes. So we never, you'll never hear me saying, there I am using an absolute. You'll never hear me saying that a application is 100% secure. So there's always a possibility that things will change, right? So you don't want to paint this picture that everything's perfect and everything's awesome when there's always that possibility that things could change. A new 0-day could come out. It's possible that maybe you missed something. A new technique could be published the day after you write your report. So things can change. So it's not good to say everything. And you also, when you did your test, For us anyway, we do it in a time box. So sometimes we don't get around to testing every single part of the application. We do the best we can in the time that we have. And we do focus on the higher risk areas first and then work our way down to the lower risk items. So we also don't want to come across as alarmists. So try not to inflate risk unless you have evidence demonstrating that that risk is there. Yeah, so that's a big one. Okay, and I have a little bit on what's in the report. So reports are fairly simple, but they, in what really needs to be in there, you definitely have to have an executive summary, a narrative of some type, and your finding details. Those three at least, and then that second item on this slide, the statements of scope, methodology, limitations, you can put those in as needed inside of a report. For us, we often don't put those in the report because they are already inside of a statement of work. So they're already in some other document of record. So there's no point really reiterating them. We can just reference them. But executive summary, testing narrative, and findings. The PCI penetration testing guidance document is good at, and it basically outlines these items as well. So it's a good reference for explaining how these things should be inside of reports. If you're on the receiving end of pen tests, I highly recommend taking a look at that and double checking that your pen test company is writing reports that include all of the necessary pieces. So details inside of the findings. Basically, you want a description of the finding. You want to explain how and where the finding was discovered. Okay, so what were you doing to discover it? If necessary, that would also be where you would say, hey, I used this other tool to do it. You want to include evidence or reproduction steps, so it's like screenshots, steps to reproduce. Make it easy enough so that somebody reading the report could go to the application, and assuming they had knowledge on how to do a pen test, they would be able to use your finding details to reproduce the same issue. And then include risk ratings and any applicable references. So some organizations like to have CVEs listed, or which are the OWASP top 10, that sort of thing. So having findings tagged that way is sometimes required. So okay, so I'm going to switch over to the demonstration. Hopefully, since my machine crashed, I didn't actually start up the VM yet, so I'm hoping that it'll still work. Again, what we're using is the web testing framework. It's on GitHub, and I'll make sure that the link to that is also available when I export all of this out to our LMS. So it'll be available to you there. Okay, so just bear with me one sec. I am going to see if this will actually start without breaking. And hope we have a window. I had all this set up and then my machine blue screened. So okay. And I realize this is probably tiny for you, but once I get logged in here, I will make it full screen. So the login for Samurai is just Samurai. Right, so Samurai for the username and also for the password. Okay, and I will see if I can get this to. Maybe it's in the wrong. Okay, there. Can we see my desktop okay? With the SamuraiWTF in there? Yep, okay, cool. All right. So I'm going to bring up Burp Suite. I actually loaded Burp Suite Pro on here just so I could show you some of those features as we go through as well. And then I'll also bring up, I'm going to test in Chrome in this case here. Both Chrome and Firefox are installed in SamuraiWTF. And if you haven't used this before, for this version 4.1 of Samurai, the way that you get to all of the menus, you just right-click on the desktop and you can see all of the tools there that are in it. There's not a ton of tools. This is not like Kali, okay? Kind of important to point that out. If you've used Kali before, you know that you get 20,000 tools or whatever it is installed with it. We're trying to keep it simple, and as I've said, that because browsers do so much for us these days, and because the interception proxies have evolved to such an extent, there's between those two, we have well over 80% of our bases covered. We don't need tons and tons of extra tools for doing web app pen testing. Okay, so while inside the VM, I'm just going to start up a temporary project. It's a little less memory intensive. So I will do that. Normally, I would run Burp Suite natively on my desktop during a pen test. So in those cases, I would set up a project, put that in an encrypted drive somewhere, and just run the test from there, and it would auto-save and so on and so forth. And it's being a little bit slow here. Just bear with it. For the applications that we're going to be testing, I'm going to take a look at two. One is Dojo-Basic. And this is a very old application. Oh, hang on a second. There we go. Dojo-Basic is a very old application. We're actually in the process of rebuilding this right now. It's just not at a point yet where we can show it. But it is an open source project, so feel free to jump in if that's your thing. The reason I'm bringing this one up is because it's a very, very broken application with some very obvious flaws in it. But it also has a lot of the, I guess, legacy way of doing testing is in it. So it's still good for demonstrating those things. The other application that I'm going to look at is this one here, which is OWASP Juice Shop. So this is an OWASP project. It's also open source. The author of this one is Bjorn Kiminich. So this is not something that that we're maintaining, but it is very well maintained and is an awesome application with a built-in scoreboard, so you can kind of run like a standalone CTF if you want. And it has lots of different flaws in it as well. So I'm not going to go through and find every single flaw in here. There's actually close to 100 challenges built into Juice Shop right now. But we'll look at some of them, and I'll at least walk through some of the process in there too. Okay, so before we start into that part, let me take just a few minutes to introduce you to Burp in case you haven't seen it. This is Burp 2.0. So it's the newer version. A few things have moved around. If you're familiar with 1. Whatever, the 1.x. The main thing that's completely different is the addition of the dashboard tab on here. Okay, this is where notice the scanner tab is gone. So scans are now managed out of this dashboard, and your event log is down here as well. So that used to be in there. Also, your issues will show up over here. The first thing that I'm going to point out is, we always point this out first, intercept is going to be turned on by default. We want to actually turn that off. What intercept does is it actually blocks each request, so it prevents it from continuing until you tell it to. And we don't want that turned on for doing a pen test unless circumstances dictate we do, especially if you consider that modern applications tend to have, they make lots and lots of requests, right? So they pull up initially a small HTML file usually, and then they're fetching all kinds of extra resources, all the JavaScripts and the images and the CSS, and then the script starts running and it starts pulling additional data into the application, updating parts of the page, and then you have a bunch of other requests with JSON that's coming in. Usually it's JSON-based structures that are being used to populate things. And as a result of all of that, of course, it's a lot of requests, and you could end up spending all of your time in this intercept tab hitting forward, 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 forward as you go through it like that, and it'll take you all day to even view one page. Long story short, just turn intercept off. There is an option under user options to set it so that it's always off when you start up Burp. So good idea to go find that. For this webcast, I'm not going to go through everything that Burp does, but I do want to point out a few things that it does. One of them is, okay, so first of all, our proxy options, note that we are listening on port 8080. So I'm going to go to, I have Foxy proxy set up. Oops. And in this case here, right before we started today, I set up a proxy configuration for Foxy proxy that goes to localhost 8080. So that way, everything that I do inside my browser is going to go through Burp Suite. Okay. The other thing I'm going to do before I actually go any further is I want to go into more tools on here and clear my browsing data. I want to make sure that my cache inside my browser has been flushed out, because I notice I have some pages loaded there. So I'm going to clear data. Okay. All right. So now I'm going to start with Dojo-Basic. So that's a simple one. And I'll just start by just refreshing that home page. And then we can see, first thing that happens, now I'm flipping over to Burp, and we can see that that Dojo-Basic has started to populate inside of the sitemap. Okay. Whoops, there we go. There's the site. Dojo-Basic. So I can keep track of what's in scope. I usually hit no to this question when it comes up about proxy history logging, especially since I have more than one application I want to add. Dojo-Basic is now in scope. I'm going to go ahead and just add Juice Shop to scope as well. And because I know that this socket IO has something to do with managing the scoring inside of Juice Shop, it's not part of the functional part of the application. I'm just going to go ahead and remove that from scope as well. So we have the scope tab here, and it has, these are the items that are in scope, and we have this one that's out of scope. What that does is any automated tools inside of Burp, they're going to check that scope first, and they'll warn you if you start doing something that you have not marked inside of scope. So it's a kind of an important thing to make sure that you're still testing with permission on the right stuff. Okay. Now, the main tab that I look at, and now that I've marked some of it out of scope, I'm going to So in case anybody missed that, this bar here that says filter, hiding CSS, whatever, that is a button. So click on that, and then you can show only in-scope items. And that way we can get ourselves back to just looking at the parts of the application that we're interested in. So stuff that we've marked as in scope. So this is the part of Burp that I use for most of my most of the time that I'm in there. Is I'm going to be looking at the proxy history, and then I'll be moving requests. So if I right-click on this request here, you can see that I can send it to other tools within Burp. Okay. You can also, as you click on things inside of the list, so we have various different requests that have been made already. Down at the bottom, we have the request in a tab, and then the responses in a tab. And I usually stick to using the raw view on there. Okay, so I'm looking at the raw requests and the raw response. And as a pen tester, you kind of get used to looking at those that way. So that's what we'll be doing there. So going back to our application, so here's Dojo-Basic. We have two applications. We're going to do the legacy application, Dojo-Basic, and then we'll look at OWASP Juice Shop, which is a much more modern application. And so we'll map out both of these. So Dojo-Basic, we have a home, we have a register, and then there's a login screen. Oops, there we go, yeah. And this was actually based on an old version of Matilda, but it has been kind of modified a fair bit since then. That's why we still have the, you see the favicon is still the Matilda one. So I'm going to create an account for us. Okay. And we don't need to save that. We don't want the browser interfering with our pen test. All right, so. Then we log in. Okay, and so then we see it's an internal employee intranet site. We have the extra stuff that showed up in the menu here, so we should look through it. We have a user info screen. This looks like one where we can make updates to the user information, which there's not very much there, but it's still something that we can play with. There's somewhere we can enter blogs. Okay. We have a view blogs, so we can take a look at other people's blogs on there. Also have an idea how many users might be in the system, or at least how many can blog. We have a reading room. So that just has a list of stuff on it. And if we click on those, it brings up a document. This Play Snake I know is broken for this because we didn't install Flash. It's a Flash-based app. There's the logout. I'm not going to do that just yet because I still want to look at the rest of what's in here. We have browser information, and then there's something called a DNS lookup tool. So we could try to look up ourselves. Right, the application that we're in. See what happens there. All right, so it actually came back. So that's, I think, all of the functionality that we have in here so far at this point. Okay. The other application, Juice Shop, so same sort of thing. All right, we'll take a quick look at this one too. We want to map this out. This one, unfortunately, is a little bit slower to load inside the VM. So just give it a second here. Or a few seconds, I guess. All right. So Now we see that we have you know, an online store of some type. Looks like we can view products on here. Maybe submit reviews on products, it looks like. There is a contact us type of functionality on here with customer feedback. There's an about us page. You know, it's a good idea to kind of look through everything that's there. There's, oh, here's a link. We want to click on links. That's a pretty ugly looking page. Lorem ipsum. Uh-oh. It's gotten slow again. There we go. Okay. It's still loading. I might need to bump up the RAM on this VM. Okay, so there's also a login. So we'll definitely want to log into this one, same as before. I don't have one already set up, so I'll go with the not yet a customer. There's a security question. And we want to look for what's changed as we log in. Okay, so one thing that's changed, obviously, is that we are now logged in. So there's a profile and a little menu here with some extra options. So we want to go through each of those, see what we can find in there, and map out all of that information. There's also now a basket, so we can add things into our basket and kind of go from there as well. Contact us. It looks like there's a complaint button too that wasn't there before, right? So there's various different parts of the application have changed. So we'll want to kind of dig into those as we map it out. And in the interest of time, I'm not going to click through every possible link, especially since the application is going a bit slow. And we'll start actually looking at what are the types of things I would look for in a pen test. So if you remember, one of the first things that I mentioned was there were 4 buckets of things that I look at. And one of those was, the first one of those is authentication and authorization and session management types of things. Well, mostly, I guess, authentication session management. The authorization kind of fits in there too, but we also look at that for when we're looking for ways to get to sensitive information. So if I look inside of my proxy history here, I can see somewhere along the way I logged in, and I'm going to go find that one. Here it is right here, okay? So here was my login. I had passed in my username and a password, and then there were no cookies that were sent in as part of that login. And then the response that came back did include a couple of cookies. Right. So, and then if I look at the next request, oops, I can see that it's cookie-based session management that's happening here. So, good to know. One thing that we would want to do in this case is try to determine which cookies are necessary for session management, like that are actually part of managing the user's state. So one thing that I like to do for that is I'll send the request immediately following a login over to repeater, or any request after that that actually includes any session cookies. And this one here is a very simplified example, which is fine for demonstration, but in reality, I mean, if you look at most web applications that have cookies in them, there's usually many cookies in there, and sometimes there's a ton of them. You have 20 or 30 various different tracking cookies that have showed up because they're the domain that you're in, maybe logged into another application that was in the same or similar domain, and so they've showed up as well. So we'll want to find out, you know, what part of the cookies that are there are actually instrumental in maintaining the user state. So what I just did there is the first thing that you should do whenever you send something to repeater, which is get a baseline request. So I hit go, I get my baseline request, and then I'm going to look down and see if there's some way I can tell that it actually worked and that I'm still logged in. And I see it right here. You are logged in as Jason. Okay, so I'm going to I'm just typing something so that I can find you are logged in later as I repeat this request and make changes to it. So the first thing I might want to do is we'll go under the assumption that that session ID is probably what is holding on to the session. So I'll hit go. That's strange. Look at that. My that doesn't seem to be the case. I'm no longer logged in once I got rid of the UID. So going back, because I can use these buttons here to go back and forth through my requests, I can see that. So when I removed that UID cookie, suddenly I wasn't logged in anymore, which means that UID cookie may actually be instrumental. So why don't I take out the session ID and just remove that. Okay, and now we can see, hey, look at that. I'm now logged in as Jason. So the only thing I need to log in is this UID. So, you know, again, this is, as I said, if you're rolling your eyes at this, this is a, it's an exaggeration of situations that we found. So this is a case of somebody's rolled their own session management. In this case here, it's silly session management, but they've rolled their own, and it's not as secure as the default framework would have. Okay, and in this case here, we can look at it and send this over to decoder, because it's encoded somehow. That %3D is telling me something. In this case here, it's telling me that this is probably base 64 encoded, right? The equals at the end is a padding, so that tells me it's base 64 encoded. So if I decode that, I have 8. It's just a number by itself. So what we might want to do is try another number in there and see if we can manipulate that. So if I try, well, I don't know, I'll just try 3. We'll encode that as base 64 encoded, and that's MW equals. So I'm going to copy that, and I'm going to paste it back over here. And we probably want these to be encoded. Okay. And now if I hit go, I am logged in, but I'm now logged in as John. Okay, so it's switched to a different person. So obviously this is really, really bad, but you know, it just shows the example as an example of some of the types of things that we want to do there. Now, if I switch over to Juice Shop now, we probably want to see how we're logged in there. So I'm looking for a post with the login. This is probably it. Yes. So I'm going to right click and send this to repeater as well. And oh, one thing I should mention here is inside of repeater, the tabs in here are editable. So I can say, instead of 1, I'm going to say this is Dojo-Basic. And this one here is Juice Shop. And Okay, so our login, we have our username, we have a password. There are a couple of cookies that get passed in. One of them looks like it's just a language cookie. Okay, so that's something else that we might look at later on as a possible injection point. And we hit go. And when we hit go in this case, we're getting back an authentication token. Okay, so this is very different. We're not getting any cookies being set. We are getting an authentication token of some type. So we'll want to try to figure out what that is. And then we also see inside of this authentication, there's, let's see, there's a token and there's also this bid and then a UMail. So the user email, I guess, is on there as well. So we have some information that's being passed back, and that's probably being used by the application somehow. So if we look at the very next request after the login, that might give us some hints. And sure enough, it does. So that token value shows up in two places. It shows up in a header. All right, so it's actually an authorization header as a bearer token, and then it's also showing up as a cookie token as well. And it looks like it's the same value in both cases. So now we have an idea how the session management is being maintained. It's token based instead of a random session cookie. And I'm betting, well, it's not really betting since I'm already somewhat familiar with this application. But when we see one of these long tokens like this, it's probably some piece of data that's encoded. So we'll bring that over to decoder. We'll again decode that as base 64 because that is the most common encoding to use for tokens. And I'll just bring this over to text-based here, and we can kind of make out what's inside this. So this is a JSON web token. That's what this means over here, the JWT. Here's the algorithm that was used to sign it. And whoops, I didn't mean to scroll. And then we can see the contents of it, of the token, show that it was success, so a successful login. Our UID, so it's, or sorry, the ID, probably the user's ID in this case here, since it's all bundled together with the username, is 14. There's a password in here. That's interesting. Again, bearing in mind that this was passed back to us, back to the client side, shows that we are not an admin, so that's false, and that may be used to update the user interface. And then where we last logged in from, there's profile image. So, and there's a few other fields in there as well. All right, so including some timestamps. So we have all of this information is all embedded inside this token. This is the way a lot of modern applications are being built. Okay, so they have this idea that we can maintain the state inside of a token, whereas previously we would insist on all of the session management being done or being maintained on the server. Now we're seeing more and more of that being pushed over to the client, and so we have to be careful how we do that. Okay, so let's take a look at some other items on here too now. So first of all, let's think of injection flaws. And bringing up this screen here, the DNS lookup, this is kind of jumps out at me as definitely somewhere where we could look for an injection flaw, because the results that are coming back, I know, are coming back from a name server's lookup. And I know that because this is PHP, it is likely just making a call out to the operating system to do that lookup. So to test that theory is very simple. I can just repeat what I did before, but then come up with some way of running another command after this one and just see if I can stack another command in there. And that's basically how simple the injection is for command injection in some cases. So I'm going to use a semicolon. Knowing that this is a Linux-based system, a semicolon will allow me to basically run one command, and then that's going to finish, and then it's going to start running another one. And I will just type ls, which should list the file system contents, if this actually works. So hitting submit, and we see it did work. So right here, I've just highlighted the results of that first lookup, the DNS lookup. And then the second down here, starting with thumbs.db and working its way down, those are all the files. So this is the ls command that actually ran and returned its information back to the screen as well. Now, it's not likely that you're going to find a DNS lookup tool on a typical business application. You may find it in I guess, device interfaces, right? So like a network device. It's not that uncommon to have something like that there. And it doesn't have to be an NS lookup type of feature for it to have this type of flaw, right? So it's anything that allows you to break out of running a command or passing a command that's going to go down to the operating system and run an additional command on top of that, or instead of the one that gets passed in. So very straightforward. Another flaw that we can look at before we run out of time here is SQL injection. And that's something that, let's switch back over to JuiceShop for this one. So SQL injection is one of the main places that we're going to look for it is on the anything that interacts with a database. So in this case here, the login appears to be part of the database, so we would look there. We might also look inside that basket system, right, or the inventory. Anything that we think might be interacting with the database, we want to test those for SQL injection flaws. I'm going to start off with the login. And the litmus test for SQL injection is just a single quote. I'm going to go ahead and pass that. Whoops, that's the scoreboard kicking in, so just ignore that. And what I got back here is just a weird error string. So if you saw that, object, and anytime we see something weird happen as we're going through a test, those are the types of things we're going to look at in more detail. So what I'd want to do now is go down to my proxy history, try to find that login, here it is right here, and see what the response looks like. Okay, and we can see in this response, oops, let me scroll that up a little bit, make it a little bit easier to see. In that response, we have an actual error message body showed up in there. So SQLite error, unrecognized token. So that's useful information. And not only do we know, not only do we see the error, but we also see what token was passed in there. So this is looks like the MD5 hash of the password that I typed in, which is kind of interesting. So we also get the, exactly where did this happen. So here's the extra quote I put in. It's nice to get an error back like this that actually shows you the SQL statement that it was trying to run. This tells you definitely have SQL injection flaw. So it's just now a matter of exploiting it somehow. So easy way to do that, in this case here, would be to do or, and the reason why we're saying or 1 equals 1 in this case, or it could be or 2 equals 2 or 3 equals 3, is you want something that you know is going to evaluate to a true every single time. So an absolute truth, semicolon, dash, dash, and I'm going to put a space in there. Even though I know it's SQLite, I should be fine with just the dash, dash. So if you think about this in relation to this error here, what I'm doing is I'm adding or 1 equals 1 on here, and then semicolon, dash, dash, and then space. So what should happen is select star from users where email equals, and then it's going to just return everything, right? Because it's anything that's true. The way that most applications are set up is they iterate through result sets that come back from the database, and in a case such as logging in, they're just going to pick the first item off that iteration. So the first person in the database, which is often the administrator. The rest of this, the end password part, is going to be commented out because of the semicolon dash dash space that I put in there, if this works. And yeah, it did. Oops, trying to get rid of the green box. There we go. And we can see, as I look at the profile, I'm now logged in as the admin. Okay. Looking back at Dojo-Basic, the same type of flaw is there as well. I want to show one other tool though, and that is, so knowing that we have this type of flaw here, so I could do the exact same payload, and I'm going to type something in the password field. I don't want it to, some other error to cause a problem. Oh, no, in this case here, it didn't work. Because 1 minus 1. Nobody's keeping me honest. There we go. All right, so we were able to log in as the administrator that way as well. But what I wanted to show was so in cases where we can do this by itself, just logging in, that's okay, but it's not super exciting. I mean, logging in as the admin definitely is, but that doesn't necessarily allow us to get to all of the information in the database. And we have to think that if we have some control over the commands that are going to the database, we should be able to get all that information out. So you could actually stack commands various different ways to do that. I am going to start off with just submitting a request, and then I'm going to open up a different tool called SQL Map, which automates that process of finding SQL injection flaws and then exploiting them. And I'll just do this quickly. I'm sure some of the folks who are watching have seen this before, but for those who haven't, you may want to see this. So SQL Map or SQL Map is a command line tool. What we need to do is we need to pass in the first the URL that we're going to post to. So this one here. Inside of Burp, I can right-click anywhere and do a copy URL. Okay. So this is, just want to double check. This is the post, yeah, that I used. All right. And then I can do, oops, dash data equals, and then I can give it my post data here. All right, so I'm going to copy that, post that in here. And so what's happening is SQL Map is actually submitting requests through that login form that I just gave it. Okay, it's not talking to the database directly, it's talking to it indirectly. I'm just going to run through it, let it do its thing. Some of this will take a few seconds here because it's doing tests for time-based attacks. Okay, so while that's going, notice that it's looking for various different types of SQL injection flaws. So it'll try like error-based, which is going to be the fastest way to exploit an SQL injection flaw, but it's also looking at blind and time-based. Well, timed is another type of blind, which those are slower to exploit, especially if you're trying to do it manually, because you're basically asking the database a bunch of questions and getting true-false Boolean type answers, right? So do you have a table that starts with the letter A? Do you have a table that starts with the letter B? So on and so forth. And that can take a while. So you see union queries, MySQL union queries are being used in there. That's how you're going to pull information out of multiple tables. Okay, so it's finished. And all it did at this point here is, because of what I gave it, it went through and it discovered that the username field is vulnerable, and it's vulnerable to both a Boolean-based blind and an error-based and a time-based blind injection flaws. So I can use that along with SQL Map to then pull information out of the database. And the nice thing is SQL Map will actually create the queries for me. So I can do --DBS, and it should list all the databases. It also remembers everything it did before, so it's much faster at this point going forward. Okay, so we can see there's the databases that are in there, and then I can do -D Samurai, and don't worry about all the commands. You can look those up online. The documentation for SQL Map is very, very good online. It covers everything in a lot of detail because there are many, many options for it. So I'm not going to go through all of them here. But then I could look at the tables. Did I spell something wrong? I did. I accidentally put 2 dashes in front of the capital D. I just want 1. All right. And then we do, so we have our tables, accounts, blogs table, and hit log. And I can do -T accounts, --, and we'll just dump the accounts table. And you can see that it's, again, remember, it's making a bunch of web requests, and through all of those web requests together is basically able to reconstruct that table fairly quickly. Okay, so. So I'm just looking through comments here because I saw a couple things pop up on there. For cases, one that was brought up, for cases where you need to extend the functionality inside of Burp Suite, by the way, there is an extensions API. I'm pretty big on that. I've written several extensions myself. I have a couple that are inside this BAP store that you can install. One of them, and I'll just run it very quickly here. Actually, I think I can do manual install because it should be already here. There's one called CO2. And so here's the extra tab that's popped up. The first tab inside of CO2, which is a collection of tools that do various different things, is SQL Mapper. And what you can do with that one is, if you don't like to try to remember all of the options, you can just send a request, a starting request to SQL Mapper, and it creates that command line for you. So then you can just copy that and then paste that into you do SQL Map space and then paste that into your command line, and it'll have all of the options that you've selected there. So kind of a convenience. Okay, so another question. I was able to get that far in Juice Shop. Is Juice Shop vulnerable to the same process in SQL Map that dumps the user databases? I have not had a whole lot of luck with SQL Map on Juice Shop, which is why I didn't use it as in the demo. It does have a SQL injection flaw, but it's a little bit tricky, a little bit complex, and I'm sure that it's got to be possible with SQL Map. I just haven't figured out the set of parameters that I would need to pass in to make it work. Okay, so another question. If you are doing an external and internal network pen test for your clients, how much testing do you do on their web apps, if any? I'll do a fair bit. I mean, that's something that we usually talk about in the kickoff call for the external pen test is, you know, as we run across web applications, how much do you want us to do with that? It's not the same as doing a full-blown web app pen test because our goal in that case is more about getting inside the system, right? You know how I mentioned before, if your goals of the test are find all my vulnerabilities versus can I get inside your network. But we'll still do that testing, and it'll be treated more like a black box in those cases. Normally we wouldn't have accounts set up for us for those. So if we can find a way to bypass the authentication or to create a user account, then we absolutely would go in and start trying to find our way in through those systems. Often what we can find is information that helps us with other things, or possibly, if we're really lucky, we find an interface that allows us to put a web-based backdoor into the system and to get us in. So, all right. So unfortunately we're getting really close to the end of the time, and I know a lot of you probably have to drop off. So, if you have any other questions, go ahead and post them. And if you have questions later on, we have so if you go to professionallyevil.com, there is a invite link on there for our Professionally Evil Slack channel. And you're all welcome to join, and you can ask questions there to your heart's content and hopefully get answers. So I usually you know, poke my head in there several times a day because we have several classes that we're including our CISSP mentorship class that we run through there as well. So so you can feel free to ask questions there, and if it's something I can answer, I will. So other than that, I think that's pretty much it. Anybody have any other questions? Okay. Oh, it looks like there was one more comment on here. All right. Well, thank you. This, like I said, I'm going to take this this recording. I'm going to put it up on the LMS, and we'll email everybody out. So I have the list of everyone who attended. So we'll get that out. Thank you.